Hello.
Hi, Gennaro. Welcome aboard.
Yep. In about 5 minutes, we'll start.
Yeah, we'll get started in 5 minutes. Thank you for joining.
Yep. I took a look at the homeworks from yesterday, the previous
Good.
homework. I mean, that's why I always look at the previous homework before we take the exam.
That's a good idea. Yeah. Because remember, the WebAssign exams are really taken from the same pool of questions
Yeah.
as the homework problems.
Yep. But
So
similar.
by understanding the homework problems, you are
I mean, if you only just I'm sorry here. If you only just only just practice on the final exam without going back to the homework, then if the question has been changed, then you don't know what to do then.
yeah, exactly right. So having seen the problem ahead of time makes it a lot easier to navigate. Yep.
Yep. It says we take our exam at 10 o'clock. We take our exam.
Yeah, let me bring that up just as a quick reminder.
More time, let us know if any more time. Okay, we'll do it on Monday morning.
Folks, we're going to get started in just a minute or two.
So it will be only just one attempt then for the exam.
Yeah, so Gennaro, the final exam is going to be very similar to the tests you've been taking. Like, for example, the Chapter 10 test that you took.
Like the previous tests.
Yeah, like the previous tests, exactly right. Yeah, let's go over that in just a minute.
But all the questions are all mixed then.
Yeah, so the final exam is going to be comprehensive of everything from the course. So it's going to be, a mix of problems from chapter 7, 8, 9, and 10. And that's why it's important to use the practice final as a way to prepare, because, you might have forgotten some of the concepts like graphing sines and cosines, right? Because that was way back in chapter 8. So reviewing this practice final is a good refresher. All right, folks, why don't we get started? Thank you for joining. So let me just start out here with the calendar. Folks, today is our next to last class, right? So Friday is our last class meeting. And of course, today and Friday, we're just going to continue to go over the practice final exam, okay? Let me remind you about the final exam, which is next Monday. So here's the final exam. Remember, it's next Monday at 10 a.m. It's going to cover material from chapters 7, 8, 9, and 10. It's going to be 20 problems, and you'll have 2.5 hours to complete.
Like
Okay?
for me, you gave me like more time, like 3 hours and 45 minutes you gave me.
Yeah. Yeah, that's right, Gennaro. All right, folks. So let me go to modules for a second because I want to remind you about one other item. First, the recordings from each one of our class meetings are available here. So you can go back and review any of these recordings. And then also, I just want to show you that there's this reference information for the final exam, okay? And that's this file I have here. So you don't have to memorize any of these items. Things like the reference circle are given to you, a reminder about graphing given to you, formulas from chapter 9, and so on, okay? So be sure to look this over ahead of time. You can use this reference packet while you're taking the final exam, all right? Folks, anyone have any questions from last time? Or any questions on any topic? All right, well, I think we left off here at problem 7. And so this one is a graphing question. And it says, graph this function cosine 3x. And notice it's also going to ask you for the amplitude, the period, the midline, and max min values. All right, well, first, let me go here for a second, and let me take a look at this cosine function. So I know the basic cosine function looks like this graph here on the right-hand side, right? So I know the cosine function starts here at 1 and then goes down and returns back up to 1. So I know the general shape of the cosine function is something like this, okay? Now on this graph, notice that it's showing the period here as 2 pi. Remember, the period is the distance to see one full cycle of the graph. All right, but let's take our example and find the amplitude and the period and the midline. All right, so let me come over here. It says the amplitude is the absolute value of A. All right, well, in our example, let me write our example. It's y equals cosine of 3x. And the general way to think about this is y equals A cosine bx. This is the general format. In our example, A is 1. We really don't have a number in front of cosine, but of course I could write in the number 1. And our B is matching up to this value 3. All right, so now let's find the amplitude. It says the amplitude is the absolute value of A. In our example, that's just the absolute value of 1. So that's just 1. So our amplitude is just 1. Then down here, it says the period is 2 pi over B. But remember, in our example, B matched up to 3. So our period is going to be 2 pi over 3. What that's really telling me is in order to see a full cycle of this graph.
And also the midline is 0, the midline.
Yep, that's right. Gennaro says the midline is 0. The midline is this horizontal line that divides the graph into two symmetrical parts. And in our example, this midline is y equals 0. You might remember if there's no vertical shift to the graph, then the midline is going to be y equals 0. All right, well, remember, I don't have to graph this cosine function myself from scratch. I'm just going to pick from several choices that WebAssign is going to give me. But here's the graph that I just sketched. I know the amplitude is 1. So that means this peak is at 1 and this valley is down here at -1.
Then you had to find the
Also
maximum
know
and
this
the minimum.
period is 2 pi over 3. That must mean the middle here is half of that, which is just pi over 3. All right, with all that, let's go and look at the graphs that WebAssign is going to ask me to think about. And in these answers, this is actually just showing us the correct answer, but let's see, why is this the correct answer? Let me blow this up a little bit to get a better look at it. So why is this graph the correct answer? Well, first I'm noticing that it matches the format of the cosine function. Notice it starts up here at 1, goes down, and returns back here to 1. Remember, we figured out that the period was 2 pi over 3. So that means to see one full cycle, which is this distance, I have to come out here to a distance 2 pi over 3. So that checks out. I also know our amplitude was 1. That means this peak is 1 and this valley down here is -1. So this graph is matching all of these conditions. It matches the shape of the cosine function. It matches the period we figured out, and it matches the amplitude we figured out.
Like to find the maximum and the minimum, like the maximum is the top part and then the minimum is the bottom part. Like
Exactly.
for the maximum here, like we found 1 and 2 pi over 3. Then for the minimum, we found pi over 3 and -1.
You got it. Yep, let's talk about that next tomorrow. Folks, I just want to mention, when you go to look at the answers that WebAssign is going to give you, some of the graphs are going to be sine waves instead of cosine waves. Remember, the sine wave starts here at 0. Right, so the sine wave starts at 0, but I know that our graph doesn't start there. So that's how I know it's not a sine wave in our example. All right, so once you know the amplitude, the period, and the shape, you should be able to pick from among the 4 multiple choices. All right, well, let's go and answer the other questions that Gennaro was mentioning. What about the maximum? Well, the maximum is really asking you to go to this graph and find the highest y value. Well, this point right here is the max because it's the highest y value. And WebAssign is asking me, what's the xy coordinate? Well, the x coordinate would be go out 2 pi over 3 and then go up to a height of 1. So it makes sense. The coordinate of this max is 2 pi over 3, comma 1. You might say, why isn't this blue dot the max? Why wouldn't I use that as the max? Well, in the conditions for this problem, WebAssign said use the first occurrence where x is greater than 0. So by telling you x has to be greater than 0, that rules this out as a candidate for the max. All right, how about the min? Well, the min is the lowest y value. So that means this point is the min. I would go out a distance of pi over 3, and then the y value is -1. So the answer here is pi over 3, -1. All right, so these answers for max and min, you can really determine that just by looking at the graph itself. So once you've selected the correct graph, the maximum and minimum can be read directly off the graph. Okay. Remember, we also did problem 6 last time, and problem 6 was a similar graphing. Let me scroll back up here. So you remember problem 6 was graphing a sine wave. Problem 7 here was graphing a cosine wave. Okay, any questions on those graphing items there, folks?
For number 8, we have to do that. Now we have to find what's the. Now we have to find what's the sine of x. We have to find.
Yeah, let's look at number 8 now. Number 8 is a question that's telling you that the function is sine of x, and they're telling me that the answer is the square root of 3/2. So another way of thinking about this question is it's really asking me what angle has its sine equal to the square root of 3/2. And notice it's telling me the interval is 0 to 2 pi, which of course is the same as 0 to 360. So it really means going around the whole unit circle, what angles, so it might be more than one, what angles have the sine equal to the square root of 3/2? Well, I'm going to go scan the unit circle. Remember, the sine is the y value. So when you look at the unit circle, the x value is the cosine of the angle, and the y value is the sine. Okay? So I'm looking for any sines, any y values that are square root 3/2. Well, here's one, and it looks like here's another. And I think that's it. There's no other angles on the unit circle where the sine is square root of 3/2. Okay? So the angles here are x equals 60 degrees and also x equals 120 degrees. If I wanted to write these in radians, it would be x equals pi over 3 and x equals 2 pi over 3. Okay, so I can either go with degrees or radians. That's up to me. Okay. All right, folks, let's go to number 9. Number 9 is going to be a similar question, but now it says the function we're working with is cosine x. And it's telling us the cosine x is 1/2. By the way, you know, when I see cosine x, I know x must be an angle, right? Because I can only take cosine of an angle. So in this question, x is an angle. And really the question is, find any angles where the cosine of the angle is 1/2. All right, so again, I'm going to go looking around the unit circle. Remember, the cosine is the y value. So let me, excuse me, the cosine is the x value. So the cosine is the x value on the unit circle. And the sine is the y value on the unit circle, right? Hopefully by now you remember that. Okay, so I'm looking, where is the x value equal to 1/2? Well, here's one occurrence. Anyone see any other occurrences where the x value is equal to 1/2? Well, as I'm scanning around, I'm coming down here to the bottom right corner. Here's another x value that's equal to 1/2, and it looks like that's 300 degrees. So the answer here
5 pi over 3.
Would be 60 degrees and 300 degrees. Or if you want to use radians, pi over 3, 5 pi over 3. So actually, you know, these two questions were pretty straightforward because really it was just a lookup based on the unit circle. Does that make sense for 8 and 9? All right, let's go to number 10. Now, number 10 is going to be different because number 10 is using this notation that's this exponent -1. It looks like an exponent -1, but remember, this is really not an exponent -1. Even though it looks like an exponent -1, this is not an exponent -1. It really means inverse function. Inverse sine in this case. So the inverse sine is, this is kind of similar to the previous example. The inverse sine is asking you this question. What angle has the sine equal to square root of 2 over 2? Okay, so when you see inverse sine, the answer you're looking for here, this answer has to be an angle.
But yeah, we're trying to find the sine of square root 2 over 2 then.
Yes, but let me mention one other important item for inverse sine. Let me come over here to this reference and let me scroll down here a little bit. So here is a note on inverse sine. And what this note is telling me is that the answer, this is the allowed answer for inverse sine. Is negative pi over 2 comma pi over 2, which is really the same as negative 90 degrees, positive 90 degrees. Okay? So what it's telling me is my answer for an inverse sine question must be an angle.
Like angle like in degrees then.
Could be in degrees or it could be in radians. That's up to you, Gennaro, right? You can either use degrees or radians, but your answer has to be an angle between negative 90 degrees and positive 90 degrees. If you have an answer outside of this interval, your answer is going to be wrong. Okay? So let's go to the unit circle, but we got to keep this special condition in mind. Okay, so let me go to the unit circle.
Jesus.
Okay, and I want to scan around looking where is the sine equal to the square root of 2 over 2.
It's in the 45 degrees.
Yeah, let me get rid of this here. So I'm looking for an angle where
Right over here.
y value is square root of 2 over 2. All right,
Right here.
well, I'm noticing here's a y value of square root of 2 over 2.
So is it only going to be like one answer or more than one answer?
Well, here's another angle that has the sine equal to the square root of 2 over 2. So I'm seeing 45 degrees as one possible answer, 135 as another possible answer. So 45 degrees and 135 degrees are possible answers. But I got to be careful. I'm only allowed to have an answer between negative 90 and positive 90. So what's my only answer then for this question?
45.
I can't use 135. This is no good because it's outside of the allowed range. So the only answer here is 45 degrees. Folks, a very common mistake is that students forget this requirement for the inverse sine. So this is a requirement for the inverse sine. Okay, so the answer to this problem is 45 degrees only. How do you know this is inverse sine? Well, because of this -1 superscript, that's what tells you it's inverse sine. The examples we did a few minutes ago did not mention inverse sine. So that's why the examples we did a few minutes ago, we didn't use this requirement about the answer having to be between -90 and +90. All right, so try to keep an eye on that. Otherwise, things can get confusing. Let's come to this example. So this example is asking me about inverse cosine. Well, let me come over here to the reference sheet, and I'm noticing this is telling me that the answer
It's 0 and pi.
Inverse cosine must be between, let me say, must be an angle, right, between 0 and pi, which is the same as 0 and 180 degrees. Okay, let me write that over here. Any answer for inverse cosine must be an angle between 0 and 180 degrees. Okay, or of course that would be 0 and pi in radians. Okay, remember again, whenever you take inverse cosine, your answer is an angle. All right, well, with that, let's go to the unit circle. And let me go to the unit circle. All right, we're looking for an angle whose cosine is negative square root of 2 over 2. Remember, the cosine is the x value on the unit circle. Anyone see any possibilities here?
For this is okay. I can't see that because you have the writing over there on the fourth quadrant.
Oh, let me clear that off.
But I see 225 over there.
225 is one possibility, yes.
And the other one is 135.
So 225 is one possibility. 135 also has the cosine equal to square root of 2 over 2. So here are the possible answers. Nora says we could either use 135 or 225. But let me go back to this condition. The answer must be an angle between 0 and 180. So
135.
Yep. 225 is no good. It's not in the allowed range. So the only answer here for this problem is 135. Okay. And again, folks, if you forget this requirement for inverse cosine, it's on that reference sheet. So you can go there and remind yourself about that requirement. All right, folks, let's do a few more examples. Let's come to this example. This one, you might remember that there are some examples like this that ask you to simplify a messy trig expression like this and try to come up with an answer that might look like sine or cosine or secant, but we want to try to simplify this as much as we can. All right, well, I'm going to go to a bunch of identities that we have. So I'm going to keep these identities handy in case we need them. Well, you might remember that a good way to get started for this kind of a question is change all functions change all trig functions to sines and cosines only. Because if you do that, usually what happens is you might end up with things canceling out or expressions simplifying. So let's do that. I want to change every one of these trig functions to be either sines or cosines. Let me start off here with cotan. Well, when I come over here to cotan, I'm seeing that cotan is cosine over sine. So I'm going to write this as cosine over sine. Okay. Then I have a cosine. Well, I'm just going to bring that down with me because I'm only getting rid of
It's times cosine.
cosines. Okay. Let me come over now to cosecant. So I'm seeing cosecant here.
Cosecant is 1 over sine theta.
Yep, here it is. Good, Gennaro, right? Cosecant is 1 over sine theta. So let me write this then as 1 over sine. And I'm just going to bring down the sine squared with me.
It should be theta, not x.
Well, Gennaro, in our example here, instead of using theta, we're using the letter x for the angle. Because notice the example uses x.
Yep.
That's why I'm using x in my examples here. Right? Doesn't matter what letter you use for the angle. Could be x, could be theta, could be alpha, could be beta. It's up to you.
Gamma.
But I want to just be consistent with the way the problem wrote the angle as x. All right, now I want to try to simplify this somehow. Well, you know, you might be tempted to cancel out a sign on the bottom with a sign on the top here. But I'm not going to cancel that out yet. Why not? Why am I not going to cancel out these signs in blue here? It's very tempting. The reason I'm going to resist the temptation is because I'm noticing this fraction on the left also has a denominator of sine. And I'd like to add these two fractions together. But in order to add fractions, you have to have the same denominator. So I'm going to leave the denominator as sine x for both of these fractions. All right, well, let me clean this up a little bit. Here on top, I have a cosine times a cosine. Well, that's cosine squared. And on the bottom, I have sine x. All right, let me multiply this fraction. Well, on top, I have a sine squared. Oops, this should have been a plus sign in the middle here. Let me fix that. Now you can see why I left the signs on the bottom, because now I have the same denominator. So when you add fractions, you keep the common denominator, and I'm going to add the numerators together. All right, but I'm always looking to try to simplify if possible. Does anyone see some kind of a simplification or substitution that I can make here? Well, you might notice on top is cosine squared plus sine squared, but that's famous. Because you might remember sine squared plus cosine squared is equal to 1. So the top of this fraction is equal to 1. So this is 1 over sine x. I could leave the answer like that, or I remember that 1 over sine is the same as cosecant. So I can also write that as cosecant x if I want.
That's what the answer says.
The answer says cosecant. Yep. So after all that work, this big, messy expression that we started with simplified down to just one trig expression of cosecant.
I mean, like when, on the previous homeworks, it doesn't tell like one of those.
Junara, this would have been in section 9.1.
Oh,
So the section 9.1 homework, I think, had a few of these examples in it. All right, folks, why don't we go to a few more examples? Clear. All right, let's take a look at this one. This one says, take this expression and rewrite it in terms of sine and cosine. All right, well, let me scroll down in my reference sheet and let me try to find a formula that might match up. Well, I'm noticing for this expression that they're giving us, it kind of looks like cosine of something minus something else in the parentheses. So
wait, we have to use some of the different formulas we have to use for that one.
You got it, exactly right. If you notice, right down here is a formula for cosine A minus B. So let me write that formula. It says it should be cosine A cosine B plus sine A sine B. Right, so I'm just using this formula that I circled in red. And I'm using A and B instead of alpha and beta, but you can use alpha and beta, of course.
Now
Right,
we have
all
to
I
find
have
the
to do is
cosine of 5
match
over
up
3.
B. Well, in our example, A matches up to the letter X, and B matches up to 5 pi over 3. So let me plug those in. Cosine A is going to be cosine X. Cosine B is going to be cosine 5 pi over 3 plus sine A, but remember our A was really an X, sine 5 pi over 3.
1 over 2 cosine.
So all I did is I replaced A. Remember, in our example, A really matched up to the letter X, and B matched up to the angle 5 pi over 3. All right, the only other thing I could do is I could simplify this a little bit, because cosine 5 pi over 3, I can go to the unit circle. So let me get cosine 5 pi over 3 from the unit circle.
1 over 2.
Yeah. So if you go around the unit circle, here is 5 pi over 3. Let me get rid of this. Hold on a second. Let me just clean up this stuff here. Okay. So I'm noticing here is cosine 5 pi over 3. And here is sine 5 pi over 3. All right, so cosine 5 pi over 3 is 1/2. And then sine x, I'm just going to bring down with me. And then sine 5 pi over 3.
Negative square root 3 over 2.
Yep. And that's the answer. I really can't do anything else.
Like if you write that on WebAssign, what happens if you write it just like that?
WebAssign should take this okay. Yep, this is perfectly okay. If you wanted to, you could just clean it up a little bit. You don't have to, but sometimes we put the fraction in front. So I could also write this as 1/2 cosine x. And I could put this fraction in front. That would make it minus square root of 3 over 2 sine x.
I mean, if you, I mean, there's like we like when I made the copies of this, I copied like the sheet copy I made, like, and also wrote down the questions, like all the steps that I had to do.
Yeah. Yep. Yeah, that's excellent. Let me scroll down, Janora. I think you might be asking about how the WebAssign answer is showing.
Yeah.
Let me just scroll down to that. And remember, folks, WebAssign takes different forms of the answer. So you don't have to have the answer exactly the way it's shown in the answer key here. But if you could see here in this green box, right? What they're typing in the green box is matching our answer here, right? So you might notice that our answer here, is really the same as what WebAssign is showing as the answer. But even this answer that I'm circling in the red box is equally correct. So either one of these is okay.
Yes.
All right, so folks, this example that we just did was really asking you to match up the expression they gave you here and recognize that it matched up to cosine. You had to recognize this really matched up to cosine A minus B. All right, let's do the next example. Next example is a little more involved, but on this one, they're asking me to take this triangle and find sine of 2 alpha cosine 2 alpha and tan 2 alpha. And I'm noticing alpha is this angle up here. All right, well, I know this is a right triangle because I could see this right angle here. So, of course, it's going to be a good idea for us to find the side C, which is the hypotenuse.
Oh, we could do a Pythagorean theorem for that one.
You got it, Gennaro, exactly right. So let's do that. A squared plus B squared equals C squared. Okay.
A is 9, then B, and 12 is B.
You got it. So this is going to be 9 squared plus 12 squared equals C squared. That's 81 plus 144 is C squared. That's going to work out to be 225 is C squared. Now I'll take the square root of both sides. And
15.
C is 15. So this side we know is 15. All right. Why don't we start out with sine of 2 alpha? All right, well, let's go ahead and go to the reference sheet. And let me...
Sine is opposite over hypotenuse for that one. So we have to do is 12 over 15 we have to do.
Yep, so let me come over here. These are called double angle formulas. So what this is telling me is that sine 2 alpha is going to be 2 sine alpha cosine alpha. So I'm going to be using this formula right here. So this is going to equal 2 sine alpha cosine alpha. All right, well, I can easily figure out sine alpha and cosine alpha because I have this right triangle.
Yeah.
So this side is the opposite side.
So sine is opposite over hypotenuse, so it'll be 12 over 15. The next thing is for cosine is adjacent over hypotenuse.
You got it. Yep, let's do it. So opposite over hypotenuse for sine. The opposite side is 12, and the hypotenuse is 15. We might as well simplify that while we're at it. I can divide top and bottom by 3. So that looks like 4 over 5. All right, why don't we do cosine alpha also? Cosine is adjacent over hypotenuse. So in this example, the adjacent side is 9. So that's going to be 9 over 15. And I'll simplify that to be 3 over 5.
Okay. This cosine will make it about, when I did the sine of it, like here I wrote, the answer I got is 24 over 25.
Yep. So sine alpha is 4 over 5. Cosine alpha is 3 over 5. So now I'm just going to multiply these fractions together. 2 times 4 is 8. 8 times 3 is 24. And on the bottom, I have a 5 times 5, so that's 25. So that's the answer for sine 2 alpha. All right, let's go to cosine 2 alpha. Now notice for cosine 2 alpha, I have my pick of 3 options. Cosine 2 alpha has 3 formulas available. So I can use any one of these formulas. Totally up to me. I'll get the same answer no matter which formula I pick. I'm going to pick the first one. It doesn't really matter, but let's pick the first one. So it says cosine squared alpha minus sine squared alpha. Well, in our example, cosine was 3/5. So I'm going to square that. Minus our sine alpha was 4/5.
Square.
I'm going to square that. All right, well, that's going to be 9/25 minus 16/25. Right, I'm just squaring those fractions. Now to do the subtraction, keep the denominator the same.
Yeah, and you get the answer
9
of
subtract 16 is
-7/25.
-7/25. Can I really have a cosine be a negative number? Is that allowed? Well, the answer is yes. Remember, if you go to the unit circle, some of the cosine values on the unit circle are negative. You might remember let me draw the unit circle. You might remember all students take calculus. Well, the cosine is negative in quadrant 2. And the cosine is also negative in quadrant 3. So yes, the cosine can be a negative answer. All right, well, let's do the last part of this. It wants to know what's tan 2 alpha.
Wait, tangent is opposite over adjacent.
Yes, now we can use this formula to figure out tan 2 alpha. But you might remember in class, we came up with a bit of a shortcut because the tangent is defined as sine over cosine. So another way to think about tan 2 alpha is sine 2 alpha over cosine 2 alpha. The reason this is convenient is we already figured out sine 2 alpha, it was 24/25.
And then I get for the tangent alpha, I got 4/3. I got.
Yeah, let's go to cosine. Cosine 2 alpha was -7/25. So I'm kind of reusing the answers I've already come up with from part A and part B of this problem. All right, well, the way I divide fractions is I flip and multiply. Okay, so the 25s cancel out here, and it looks like I'm ending up with -24/7.
That's what I got too as well. I mean, I used the tan theta formula I used for.
Yeah, and if you prefer to use this tan 2 theta formula, then of course please do that. You'll get the same answer, but I think it's going to be a little more work.
But you did it like a different version. You did it.
Exactly, it's a different way to get to the same answer.
Doesn't matter like which formula you use then.
It doesn't matter what formula you use because you'll end up with the same answer either way. It's whatever formula you think is a little easier to work with. All right, folks, we're almost out of time, but why don't we do 1 or 2 more while we're here?
Oh, this one for number 15, you have to do, the only thing you have to do is just 33 times 2, then you get 66.
Yeah, here's the trick to number 15. Number 15 says simplify, but do not evaluate. So what I'm going to do is try to see if I can match up this formula they're giving me to one of the formulas that I have in my hip pocket. Notice here is a cosine squared minus sine squared expression. And that's equal to cosine of twice the angle. So let me write our formula here. It says if you have cosine squared theta minus sine squared theta, you can really write it as cosine 2 theta. Well, if I do this matchup, I'm noticing theta really matches up to 33 degrees in my example. So on the right-hand side, I could just think of this as cosine 2 times 33. And of course, that's just cosine 66 degrees. Remember, it said do not evaluate, so that means this cosine 66 degrees is the final answer. All right, so folks, in this example, it was really just kind of a pattern matching. You took the expression they gave you and tried to match it up to one of these formulas, and it matched up to this cosine 2 theta formula. All right, folks, how about if we do one last example? Should we go to number 16? So this one says, rewrite the product as a sum or difference. Now remember, the word product means multiplication. And what they're telling you is this is really a sign multiplying another sign. But they want you to rewrite it as either an addition or subtraction. Well, of course, I'm going to go to my handy formula sheet and see if there's a formula that will help me out here. So I'm looking for a formula that will change over from a sign times a sign into either an addition or a subtraction. Well, you might notice this formula here exactly fits what I need, because it's sine A times sine B, and then it's going to be rewritten as a subtraction. All right, so let me write this formula over here. It's sine A sine B, and that's equal to 1/2 cosine A minus B minus cosine A plus B. All right, so let's take this expression they gave us and kind of plug in. So it's 24 sine 18x sine 11x.
Oh, now the thing we have to do, the problem is that we have to do 24 times 1/2.
Yep. So I'm going to bring down this 24 with me.
That becomes a 12. That becomes.
Yep. Now let me substitute in for this expression. And I'm going to use this formula, of course, but I'm going to replace A and B with A equaling 18x and B equaling 11x, because that's the way our angles match up to this formula. All right, so it's going to be 1/2 cosine of A minus B.
And I got the answer of 12 cosine 7x minus cosine 29x.
Yeah. Now let me plug in here A plus B. That's 18x plus 11x. Now I'm just going to clean this all up. In the front here, I have a 24 times 1/2. Well, that's just 12. And then this is going to be cosine 18x minus 11x is 7x. And in the back here, 18x plus 11x is 29x. This is the final answer. Just be careful that this 12 has to be multiplying this whole bracket here. So you need this extra set of brackets or parentheses to make it clear that the 12 is multiplying that whole expression.
So that's the answer?
This should be the final answer right here.
But if you check on the answer key, it's like way different.
Let's check here. Now, Gennaro, one thing the answer key might do is it might take this 12 and multiply it inside the parentheses. I could do that. So that would be 12 cosine 7x minus 12 cosine 29x. Of course, that's another possible answer. Let's go and take a look at the answer key. Actually, what I'm going to do quickly is I'm just going to bring that up in a separate file so I can put it side by side. So let me put the answer key side by side. And this is problem 16. Yes, no, so it did leave the 12 out in front. So what I wrote here in red.
Yeah. Besides a bracket, they put a parenthesis.
Yeah, so yeah, Janora, let me get rid of this for a second here. Let me get rid of this. Yeah, so you know, a parenthesis and a bracket are really the same thing. So you can use them interchangeably. So if instead of using a bracket, I wanted to use a parenthesis here, I certainly can't. That's up to me. So a parenthesis and a bracket are really interchangeable. Okay. The only reason you might use a bracket sometimes is if you have like many parentheses, it gets confusing to have a lot of parentheses in an expression. So sometimes it's easier to recognize by using brackets instead of parentheses, but either way is okay.
Yeah.
So parenthesis, bracket are really equivalent. All right, folks, any questions on any of these examples that we've done today? All right, well, on Friday then, it's our last class. We'll pick up with number 17.
All the way
And
to
then,
23.
Yep, we only have about a handful of problems left to do. So we'll do those on Friday. Again, folks, if you can, please be sure to finish up WebAssign because the WebAssign closes on Friday, right? So be sure to finish all the WebAssign homeworks.
It'll be closed by midnight, Friday by midnight.
Yeah, by Friday, May 1st at 11:59 p.m. All right, folks, try not to leave that to the last minute because you want to give yourself time to get help. So please try to finish that. And if you have questions on Friday, we can go over any homework questions and we'll also finish up this practice final. All right, folks, if you have no questions, feel free to log off. Thank you for joining. But if you do have questions, feel free to ask any questions you might have.
So only just 20 questions on the final exam.
You got it. Exactly right, Gennaro. Yep, 20 questions.
All right.
On the actual final exam.
All right.
All right, folks, if there are no questions, I will close out.